Good morning, friends. This is Hasmuka here. Chapter second topic is example 2.15. Let us consider an equation 1 upon 2 mv square is equal to mgh, where m is mass of body, v is its velocity, g gravity means acceleration due to gravity, and h is its height. So here check this equation is dimensionally correct or not. So first we take from left hand side is equal to 1 by 2 mv square. In this case here we know that 1 by 2 is constant value. So is equal to m means dimensionally m1. Now this is the v. V is equal to, we know that m0 L1 t minus 1 means m0 L1 t minus 1 whole square. So final equation is equal to m1 L2 t minus 2 for left hand side. Now for right hand side is equal to m means again m1 for acceleration due to gravity. Here we know that acceleration dimensional formula is m0 L1 t minus 2. So now again m0 L1 t minus 2, and last one is height means distance. So L1. So final equation is equal to m1 L2 minus t minus 2. So here left hand side is equal to right hand side means this equation dimensionally correct. 16. Here k is equal to m square v cube. Second equation is k is equal to 1 by 2 mv square. Third is k is equal to ma. Fourth is k is equal to 3 by 16 mv square, and last one is k is equal to 1 by 2 mv square plus m. Means left hand side is equal to right hand side or is not equal to right hand side. So first here k, here we know that k is kinetic energy. Dimensional formula is kinetic energy of dimensional formula m1 L2 t minus 2 is equal to m square right hand side for v cube, velocity m0 L1 t minus 1 cube. So final answer is m square L cube t minus cube. Means here kinetic energy is not, means first equation is ruled out and not equal to right hand side is not equal to. In second case again here we know that kinetic energy m1 L2 t minus 2 is equal to 1 by 2 constant value. M is mass of body, m1 velocity, dimensional formula m0 L1 t minus 1 square So final answer is equal to m1 L2 3 minus 2. In B portion, here we know see that left hand side is equal to right hand side. Now third one is m1 L2 t minus 2 is equal to 4m m1, and for acceleration m0 L1 t minus 2 m0 L1 t minus 2. Final answer is equal to m1 L1 t minus 2. Here again left hand side is not equal to right hand side. Next equation is K is equal to 3 by 16 mv square. Dimensional formula for kinetic energy m1 L2 t minus 2 is equal to 3 by 16 constant value. Again m means mass of body m1, for B m0 L1 t minus 1 square, so is equal to m1 L2 t minus 2. Here again left hand side is equal to right hand side, means dimensionally corrected. Last one equation is m1 L2 t minus 2 is equal to 1 by 2 constant value m1 for velocity. Next is for velocity, in this case L1 t minus 1 square plus m1 into m0 L1 t minus 2. So final is equal to m1 L1 t minus m2 L2 t minus 2 plus m1 L1 t minus 2. Again left hand side is not equal to right hand side, so here equation B and equation D is correct for kinetic energy. Left hand side is equal to right hand side. Three equation A, C and E rule out from left hand side is not equal to right hand side for kinetic energy dimension. 17. Consider a simple pendulum having a bob attached to a string that oscillates under the action of force of gravity. Suppose that the period of oscillations of the simple pendulum depends on its length small l, mass of the bob small m, and acceleration due to gravity g. So derive the expression for its time period using method of dimension. Here we know that we have t is equal to KL, t is equal to KL G M, X, Y and Z. In this case t is equal to KL G M. Here K is dimensionless quantities, constant value. L is length of simple pendulum. G is acceleration due to gravity, and M is mass of ball. Now by considering a dimension on both sides, so here we know that in first case m0 L0 and T1, M0, L0 and T1 for capital T. Now is equal to K is constant value, dimension less. Okay. Now next is small l, means L1 x, L1 x. Now second is small g, acceleration due to gravity, acceleration due to gravity. So equation is dimensional formula m0 L1 t minus 2. Okay, m0 L1 t minus 2y. Now last one is mass, means m1 z. So is equal to here m1 means L1 means x, L1 plus y, first one, for t minus 2y, and m z, m z. Now next is, here we have simply from the comparison between left hand side is equal to right hand side. In the first case, x plus y is equal to 0, because on left hand side L0, so is equal to 0, x plus y is equal to 0. Now next is y, means y is equal to, here we select minus 2y is equal to 1, means t raised to 1. So here t minus 2y means minus 2y is equal to 1. Right hand side is equal to left hand side. And last one for m is z is equal to, last one is z is equal to 0, means m0 is equal to z. Now next, x is equal to 1 by 2, y is equal to minus 1 by 2, and z is equal to 0. Solve this equation. So final t is equal to k constant value, l 1 by 2, and g minus 1 by 2. Because of k constant value, l x means x is equal to 1 by 2, l g means y is equal to minus 1 by 2, and mz means z is equal to 0. So t is equal to k under root l upon g. But actually here k is equal to 2 pi, means 2 pi under root l upon g.